Hello, welcome to chapter 13 in Java programming. So today we are going to go through another new concept. Again, it's not terribly crazy of a new concept. We are going to look at file input and output. So we're going to start off by describing computer files and how to find them on your hard drive. Now, when we're talking about files, we're talking about something that is not already within the program. It might be stored on a hard drive or a thumb drive or on a web page. So we're going to learn to use the two new classes, one called path, one called files. We're going to describe file organization, streams, and buffers, and how they all work together. We're going to use Java's I/O classes to write and read from a static file. We're going to create and use sequential files. We're going to look at and kind of investigate random access files. We're going to learn how to both read and write to a random access data file using Java. So first, let's look at computer files as a whole. Computer files there are different types. So the first type is a volatile storage, and a volatile storage is temporary. Okay, your computer's random access memory, or RAM, it is a volatile storage. It is only temporary. It is only valid for when the computer is up and running. Once the computer shuts down, that memory is wiped and it starts cleaning up every time. Another type of storage is a non-volatile storage, and it is the opposite of the volatile, which means that non-volatile is permanent. These are your files that you usually save locally. You don't lose what's in them when the computer loses power as long as you keep saving, right? Now, a computer file is a collection of information that is non-volatile, okay, stored somewhere on your computer system. So there's a few different pieces that we have to be able to decipher when we look at a computer file. So where is a computer file stored? So typically they're stored in permanent storage devices, such as hard drives, zip drives, which I don't think they actually make anymore, but that's okay. Our book does say it. USB drives, cassettes, CDs, cloud storage, things of that nature. There are two categories that we're going to look into, and it is based on how the data is stored within the file. So there are two ways. One is a text file, which basically means that if you were to open it, you could read it with, the human eye. And the other type of file that stores data is considered a binary file. This is written in binary, and so it is written in the computer's native language, and typically it just looks like a bunch of jumbled mess to the human eye. We can look at different types of files. So data files, that's going to contain facts, figures, data of some sort. The other type of file is a program or application file. These are the files that you use to start up applications such as, say, Word or Excel or, PowerPoint. It's going to store the instructions on starting a software program. Okay. Few different places we can look for files. Number one is the root directory. The root directory is the lowest common denominator of base directory, okay? Typically, though, we organize our files into folders, or we call them directories, depending on your operating system. In Windows, we call them folders, and you can organize folders. So say for this class, you've got a folder called Java Programming, you've got a folder called Chapter 13, and then you may have a folder called Assignment 1, okay? And it kind of drills down into those folders. Now, the path is where something is located, and it is the complete hierarchy of those folders. So you may see something like C:\users/ your username / documents / Java / chapter 13 / assignments. That whole entire location is considered the path. Now, when you work with files in an application, okay, so there's a few things that happen when, say, you might be in Word or another application, or when you write yourself. First, you have to determine whether the file exists, okay, and if it does exist, where is it? Okay, so you need to know the path of it. You need to know how to open a file. You need to know how to write information and read information from that file. A few other things that we do is we do close files, which prevents it from additional writing further down the line after we open it. And finally, delete a file. In Java, we have a few classes that will help us do all of these certain things. We've got this path class, okay? It's going to create an object because it's a capital P, so it creates an object that's going to contain information about the files or directories, okay? It's going to be associated to that path and that location of where those files are. The second class is called files, and it's going to perform operations on the files and the directories. That's where your read and write and open and close. They're going to be within your files. They're in a new package, java.nio for input output .file package, okay? You're going to have to import this in order to use both the path and file classes, okay? So again, it's java.n input output io.file. When you create a path in Java, first you're going to have to determine what the default is, okay? Every operating system has a default file system. Okay, the way we do this in Java is we actually say file system. It's a data type. It's going to be an object, and we're going to call it something. So fs, this is our variable, and we're going to say file systems.getDefault. Okay, so it's going to be where the default is for that operating system. Windows has a few different defaults. Typically, it might be in your users / documents. Unix has a different set of root, and Mac iOS actually has a different set as well. To define a path, you can use something like a get path. Okay, there's a get path method. So your path, you send it a variable, equals the file systems, right? Get path, and then you send it the path. There are two different ways to enter a path. You can either do an absolute path or a relative path. An absolute path will find the location every time. This is an example of an absolute. You're starting with the drive, so you're basically going back to the beginning and starting from scratch. So you're starting with the drive, you go down into each of the folders. That's an absolute. A relative path, on the other hand, means that you are dictating what the path is relative to where you are. So typically it won't have the C colon, and it may just have, so just ignore like this part right here, and it'll just have /chapter13/data. It means wherever my root is, in that root file, there's going to be a folder called chapter 13 and then a file called data.txt. There are a few methods that are good to remember and keep in our toolbox, okay? We have a toString, so that is going to be the path, and it's going to get rid of those double backslashes, okay? The get file name, it's going to get the file or directory noted by whatever path that is, okay? Get name count, that's going to be the number of elements in the path, and each element is going to be a folder or separated by those backslashes. The get name is going to return the name and the position of the path specified by the integer path parameter. So you can kind of look it up and break it up into different elements, kind of like we do in array, but I wouldn't go that far as saying it's like that. Getting information about your path. Here is an example. Here's your path, get, and you've got your absolute path here. Okay, so int count file path, okay, which is your path, get name count. Okay, remember what that's going to do here. It's going to say returns the name of the position of the path specified by whatever integer. Okay, it's going to get the whole count of how many. 1, 2, 3. Okay, the file name is, there are how many elements in the path, and you can print each element by doing get name. You can convert a relative path to an absolute one. Remember, I said relative path is from where you are, you add on and drill down into these folders. So if you want to convert a relative to an absolute, okay, basically what you have is your full path is going to be path to absolute. Okay, there's a method called toAbsolute. What that's going to do is it's going to go get your directory of where you are as an absolute path and append to it the relative path that you gave it. Checking file accessibility. This is important, especially for error checking, which we talked about last lecture. Here you can see in a try catch, it's the best way to determine if a file is there or not, because if the file is there, it will hang up your program. But this is an exception that we know about, so we can take care of it ourselves. So here, get system check access. Okay, if the access is granted, it'll go to file can be read and executed. So it means that I see the file, I can access the file, let's work with it. If this check access has a failure, it'll go into the exception. And remember, IO exception, input output exception, and it'll say it cannot be used for this application. Okay, this is a perfect example of why we would want to use a try catch, because if you cannot find the file and you cannot access the file, if you try to do something with the file, you're going to get an error. You can also delete a path. So if you would like to create a temporary path to use by the program and then delete it when you're done, something of that nature. Here again, we've got our try catches. Try catches are very important when we're dealing with file-based systems, because we can't always be sure that those files will be there when we need them. Okay, so here files.delete, and you send it the path. Okay, if it works properly, it says file or directory is deleted. Now remember, when we talked about try catch, we said go to the most specific first and then back out. Well, this is doing something very similar. If there is no such file, it'll say no such file. If it says directory not empty, you're going to get a specific message saying your directory is not empty. If you're getting a security issue, you're saying no permission. Your bucket here is your IO exception, and that's just going to say, hey, it's not one of these other ones, there's something wrong. Okay, this helps with your debugging, because if I just say files.delete and do one catch, I don't know, does it mean that the file doesn't exist? Does it mean that the directory is not empty? Does it mean I don't have permission? I don't know what those specifics are. Using multiple catches like this allows me to drill down into what the problem actually is. You can also determine file attributes. And when I talk about attributes, I'm talking about size, creation, is it read write, things of that nature. So here there are read attributes, okay, and you send it your path, and there are basic attributes here. And you can get things like a creation time, modified time, and the size of the file. Okay, sometimes those things are good to know, because if your file is going to be too large, you won't be able to read it in. File organization, streams and buffers. So when you need to retain any data for any significant of time, we're going to save it on a permanent storage device, right? The best way to do this is to file it in an organization where you are easily able to find it in the future. So, for example, businesses can store data in a hierarchy, and I use hierarchy all the time. Like I said, I would do something like, I actually have a folder system that says, like, what term this is, what class this is, what lecture this is, and then whatever's in there. Okay, it makes it extremely easy to access in the future. But let's look at this. We've got something called a file here. That's the employee file. You've got records, you've got different fields, and then, we can even break these down into characters here. Okay. What we can do is, in sequential file access, each file is stored in order based on some value. Okay, it's based on some field. So what we can say is something like a comma separated value, or a CSV file, if you've ever seen one of those. You can create a CSV file from a spreadsheet program such as Excel. All it is it is taking the data, and in between chunks of data it puts a comma separated values. Okay, it is sequential access because it just reads the file from beginning to end, and anytime it sees a comma, it creates a new item. Okay, It's one of the fastest ways to read in a file. It is one of the most common file types to read into a program is a CSV in many different industries. So a CSV is something that's good to know. When you open a file, you're actually creating an object, okay? And what you're doing is you're associating stream of bytes with it. So when you open a file, you're allowing it to have access to be in this stream. Okay, when you close that file, you're closing that door. It is no longer accessible to the program. One of the big things to do is to make sure that you are closing every file that you open. Okay, leaving files open can leave them open to security issues. It can leave them open to accidental deletion and things of that nature. Now, what is a stream? Because we did say once it's open, we have this stream. So a stream is where your bytes are going to flow into your program from the input and then out of your program to your output. Okay, your stream only goes in one direction, just like a stream does. So input comes in one way, output goes out one way. One in, one out. Okay, think of it just like a river or a stream. You've got basically when you open a file, you have a file here with an input stream. Your file is going to be read only and is going to be read into the application. The application is going to do something. You can then also open a file for output to write. So anything that the application is going to create or want to save, you can go through that stream into the output file. Okay, remember, one way only. This is not going to be an input output. This is not going to be input output. It's one way. We also have something called a buffer. We've talked about buffers a little bit before. We talked about a keyboard buffer, remember, where it kept information kind of held in temporary storage. Well, in the most general way, buffers is the memory location where bytes are held after they're either input or output before they're sent to the actual final permanent device. Okay, when you use a buffer, it does improve your program performance because you're collecting like a large amount of data and you're dumping it all into a file at once, or you're reading in a bunch of data and then dumping it all into the application at once. There is something called flushing, and this is what we do when we use the keyboard buffer to get rid of that new line that's at the end. Remember, we kind of have to read that new line to make sure that that buffer is cleared out. Flushing is going to clear out anything that may have been sent to the buffer and got stuck there. Okay, so anything that's not been either input fully or output fully, it just wipes everything clean and it allows us to start over. Using Java's input-output classes, we have an input stream, an output stream, and a reader. We've kind of used reader, I think, a little bit way back in the beginning, but we didn't really actually talk about the theory and what goes on behind it. These are three abstract classes that are containing your methods to do your input and output. Okay, we've got our system.out. We've used system.out since day one. Okay, it is actually a print stream object defined in the system class. Okay, we use our system.out.print, our system.out.println, those right? System.error, okay, typically used for error messages, but here's your object kind of hierarchy. We've got an input stream, output stream, and a reader. We've got a buffered reader and a buffered writer when it comes to the reader. Input, we've got file input stream, and then a buffered file input stream, and a filter input stream. Output, very similar to input, we've got file output, filter output, and then buffered, and then we have this final print stream down here. Some important classes to keep in mind when we look at output, okay? Input stream, file input stream, buffered, okay? So your input stream is going to be your abstract that contains the methods for doing your input. Okay, remember what abstract meant. We're not going to create an instance of that. It's there for us to use the methods that are already there. Your file input stream, that's your child. That is going to be your capability to read from disks. Buffered input stream is a child of the filtered, which is a child of input. We just looked at that. And it's going to handle input from a system standard input device. Okay, this is your keyboard. So there's your difference. File, keyboard. Again, the same three for output classes. Your output is your abstract, your file output writes to your disks, and your buffered is typically your standard whatever display it is, typically monitor, printer, or something of that nature. Come down here, we have print stream. It is also a child of filter output stream, okay, and system.out is pretty much the one that you're going to be the most familiar with, and that is a print stream object. Finally, we have reader. Down at the bottom, we've got reader, buffered writer. So reader is going to be your abstract class. So it's only going to have the methods that we want to use. Your buffered reader is going to read your text from an input stream, okay, buffering the characters, and remember I said it's more efficient when you do it buffered because it's going to read in more at one time. Same thing with the buffered writer. It writes efficiently, so it's going to collect a bunch of data. Instead of writing character by character, it might take the entire name and then write the name. So that's a very, very basic example of what the differences are. Now, writing to a file, first you're going to have to assign the file to the output stream. Okay, then you're going to have to create a buffered output stream object, okay, and then assign it to the output stream. Okay, remember we're dealing with these abstract ideas that we talked about a couple classes ago. So you're going to create your file by using the path, and we're going to use the method new output stream. Okay, now a few things to remember is that it will create the file if it doesn't already exist. Okay, if it doesn't exist, it's just going to create it. Okay, there's no errors that are going to be there. It's going to open the file for writing, and it's going to return the output stream that can be used to write the bytes to. Okay, so it's going to create the file, it opens it for writing, and it returns the stream in which we can use to do that communication. Standard open option constants, there is write, it opens the file for writing. Append basically means that it will add anything that you send it to the end of the file without actually doing anything to any of the data already in the file. Truncate existing will truncate the existing file to 0 bytes, so the file contents are completely replaced. Okay. Create new creates a new file only if it does not exist. It throws an exception if it already exists. This is going to be the difference. Remember, we said if it doesn't exist before, it just creates it. The create new is going to create it, and if it already exists, it's going to throw an exception. Create opens the file if it exists, it creates the file if it does not. That's what we just talked about. And delete on close. So when the file stream is closed, and this is going to be for your temporary files, it will actually delete the file. Okay, so that file is only going to exist for the duration of the program, as long as the program, executes and closes properly. So let's look at an example of writing to a file. We have our new import here, your nio.file. Okay, we've got a few other ones that we also put in here. We've got the standard open option. Okay, so I've got a class. This is going to be a file out. Remember, this is writing to a file. First thing we have to do is declare our path. And so here's where I'm going to put it in the absolute path on the C drive in the Java chapter 13 grades.txt. Down here we've got an output stream. We've created an output stream. We just set it equal to null at this point because we need it set equal to something. And remember, we're going to replace it here in a minute. Here in our try catch, here's where we're creating our new buffered output stream. Okay, remember the output stream is the abstract, the buffered output stream is the class. So we're going to have a new class, and we're going to send it, we're going to do a create, which is going to create the file if it doesn't exist, and if it does exist, we're just going to open it, and we're sending it the path. Okay, up here is path as file. Output, okay, that's my buffered stream. We're going to write the data. Then we're going to flush out that buffer. We're going to make sure everything that was put into the buffer is given to the file. Then we're going to close that file. Now we did a lot of file manipulation here, a lot of back and forth, but so we just put a basic catch with a basic error message. Okay, but very easy to read and write from a file. Okay, let's look at read from a file. Whoops, reading from a file. Just as we use the output, we're going to over here use input stream buffer. Okay. New input stream buffer. Here, input stream, new input stream buffer. And we send it the input. Okay. Here, the input is the input stream with the file name. Okay. Use reader.readline. That looks pretty familiar, right? We use that same thing for the keyboard. So reader.readline, and then again, here's my close. Make sure we close our files. Okay. Let's look at some methods, some of the methods that are very important. Close. Okay. Read reads a single character. Okay. Read, and then you send it a type, is going to read the characters into a portion of the array, okay, from position off to length. Read line reads the whole line. We're kind of more familiar with the read line. And skip will actually kind of skip over characters. Okay. Let's look at creating a sequential data file. So for these, we can use the buffered writer because we can create our sequential data and use the buffer and dump it as a whole. Okay, remember its opposite is the buffered reader, so we're going to use buffered reader and buffered writer. It writes to that output stream and it's going to buffer the characters. Okay, the class has 3 overloaded write methods, so that way you can use the same method, and whether you're sending it characters, arrays, and strings. Okay, you can send it any of them. So if I look over here at my code, everything looks quite familiar except for here's my new lines. Buffered writer writer equals new buffered writer. Okay. System.out.print. Okay, so that's going to print. ID is going to get the ID. While you're not quitting, enter the name for the employee. Okay, so what you're doing is you're getting from the user an employee number, a pay rate, and then you're going to basically keep looping through here until the user puts in quit for ID. Now, here's my new code down here. Writer, and this is what is going to allow me to write it to a file instead of just manipulating it and spitting it back out to the monitor. Writer.write s, which is a string that I created up here, from 0 to length. Now, the way I created s, I have a delimiter. Now, my delimiter up here is my comma separated value. We're writing a CSV. Okay. So I'm going to have the ID, comma, name, comma, pay rate. That's what my string is going to look like. So I'm writing from s from 0 to length. So I'm writing the entire string. Writer.newline, so it's going to put a new line, and then it's going to basically keep going again. Here at the end, I make sure to close what I'm writing to. Again, some methods. Your close is very important. Your flush is very important. You want to make sure everything's out of that buffer. Your new line is going to separate, do a separator, a character return. Okay, and then you've got your 3 writes. You can write a single character. You can write a character array from position, and this is the one that we just used, okay? Actually, we used the string. A string from position off to position length. So your offset and then your length is basically what off is. Here we can do the same thing with an array from an offset to a length or the entire array. Creating and using sequential data files, this right here does pretty much the same thing. S equals reader.readline, reader.close. Okay, so what this is doing it as an input stream instead of an output stream, but it's very similar. Input stream, buffered reader instead of buffered writer. We're going to use our read line, just like we did for keyboard. And then we're just going to loop through and read each line of the file. Now, random access files are a little bit more difficult. So sequential files, we are accessing the data within it from beginning to end, almost like you're reading a book, okay? It's good for batch processing. If you've got many different records of the same thing, it can be inefficient, okay? I like to think of it as like a spreadsheet where each column is separated with a comma, things of that nature. Real-time applications, they're going to require kind of immediate record access while your clients are waiting, okay? Sometimes sequential files could take longer periods of time based on the length of your file. A real-time application is an interactive program. It may be reading and writing as your users are doing something. So random access files, the records are going to be located in any order. A lot of times we call these direct access or instant access. We use an object called a file channel. Okay, this is how you're going to be doing your reading and writing to these types of files. You can search for a specific file location, and you can actually start these operations at any location. Remember, when we used the buffered, we started at the beginning, we went to the end. Very sequential. There are wrappers, so you can encompass an array of bytes into a byte buffer by using a wrap. Okay, these are very similar to those wrappers with the capital int and the capital D for double, things like that. Your file channels have very different methods. You do have an open, okay, that is going to open your file. You do have a position, that is going to be the channel's file position. You also have a way to set the file position. Okay, you can read a sequence of bytes from the channel into the buffer. You can return the size of the file. You can also write a sequence of bytes to the channel from the buffer. Okay, very similar to the sequential. Now, you can see here we've got a file channel, which is different. And within the try-catch, it's a little different. Okay, we still have our try-catch for our exception because we are still working with input-output. So file channel equals new byte channel. Let's start at the beginning, position 0. While you still have things in the output, okay? Out is your byte buffer, right? You're going to write it, okay? Then you're going to rewind your output buffer. You're going to go to the file in position 22. You're going to write a bunch of stuff out from wherever that location is, okay? And again, you're going to rewind. Rewind is basically setting your buffer back to the beginning. You're going to go to position 12. While it has data in it in that location, you're going to output it. You're finally going to close it, okay? Access a particular record, you send it that position. So that's where we had those positions in the previous, here, let me go back here. Position 22, you went to position 0, 22, and 12. Okay, so you're going to use position. Now, n minus 1 times 50. Place the records into the file based on a key field, okay? So your key field is going to be the one item that makes that record unique from every other record in this file. Okay, there's got to be a key field in these random access data files. Otherwise, if you've got if you've got a duplication within the key field, you're never going to find the record that you want. Okay, so here we've got a default record is going to be a line.separator, and here's your loop, writer.write from 0 to length. Okay. Reading records from your random access file, you can do it sequentially or you can do it randomly. Okay, so if you know what you're looking for, you can do it randomly. Otherwise, sequential works just as good. If you're going to read from it sequentially, you can read through each one of the records, but depending on how many records you have, that's what's going to take your time. So if you've got 1,000 records in a for loop, okay, it has to go through that for loop 1,000 different times. When the ID number value is 0, no user enter records are stored at that point. The application does not bother to print it. Okay, so it's looking at that key value. In this case, your key value is going to be your ID number, which means every single employee has got a unique ID number. If that ID number is 0, it's not really an employee and it just skips over it. Now, to access a random access file randomly, lots of randoms, you can display your records in order based on the key field, okay? You don't need to create a random access file and waste computer storage, okay? So instead, what you can do is read them in and then sort on the key field. Okay, we talked about sorts a little bit already. By using a random access file, you're going to retrieve specific records from the file directly without reading through the other records. So you're going to basically search for the one that you're looking for, pull it out. Search for the next record, pull it out. Okay, it's a little bit more confusing on the programmer's end. As you can see, the code gets a little bit out of control, But as long as you're commenting properly and you have things organized well, it is easy to follow. Now, don't forget that a path name might be relative and you might need to make that path absolute before accessing it. Okay, you need to make sure that file's there. Don't forget that the backslash character starts the escape sequence in Java, so we need to use a double backslash, especially when we're working in the DOS operating system. Here's a summary of everything that we talked about today when it came to file inputs and outputs. So, as always, I'm available for any questions, comments, or concerns via email or my office hours, and happy coding.